Welcome to aminacademy.com. In Discrete Mathematics regarding mathematical induction, let us do some solving problem. Look at this example. Use mathematical induction to prove that 2 power n is lesser than n factorial for every integer n with n equal to greater or equal to 4. That means we have to prove 2 power n is lesser than n factorial for any integer n more than n equal to 4 or equal to 4 or more than 4. That means 1, 2, 3 up to n is 1, 2, 3, it is not true. Here just let p of n equal 2 power n lesser or lesser n factorial. The basic steps we know that here n equal to 4 because it is equal to 4 and starting greater than 4, and p of 4 is 2 power 4 is lesser than 4 factorial. 2 power 4 is 16 and 4 factorials 4 into 3 into 2 into 1 is 24. Of course 16 is lesser than 24. That is basic step is true. So first the basic step is true here. Now for inductive step, let k is greater or equal to 4, that is let k is any integer greater than or equal to 4, p of k equal, substitute n as k, that is 2 power k is lesser k factorial, it is true. Because already the basic step is true. Here p of k greater than or equal to 4, it is true. Suppose 2 power 5, k is 5 means 2 power 5 is 32 and k factorial is 5 factorial is 120. Of course it is 120 is greater than 32. Now inductive steps k, p of k plus 1, that means we are adding 1 for k, it becomes p of k plus 1. 2 power k plus 1 is, we can express as 2 power k plus 1 is 2 into 2 power k by definition of exponents. That means it is of course it is greater here because 2 power k is already greater, k factorial is greater than 2 power k, there here multiplication with 2, of course it is greater than this. This is definition of inductive hypothesis. Then here further it is k plus 1 k factorial. K factorial is written as here k plus 1 and k factorial is because here 2 is lesser than k plus 1. Therefore, it is equal k plus 1 factorial. Definition of factorial function. We know that k plus 1 into k factorial is k plus 1 factorial. So, we proved inductive steps for p of k plus 1. So, therefore, we can say finally 2 power n is greater than n factorial. Therefore, 2 power n is lesser than n factorial where n is greater or equal to 4. It's a proof by induction. Next question. Use mathematical induction to prove that 7 power n plus 2 plus 8 power 2n plus 1 is divisible by 57 for every non-negative integer n. That means if you put any integer for n, that number is of course divisible by 57. We have to prove it. P of n expressed as 7 power n plus 2 plus 8 2n plus 1. So basic steps, p of 0, basic step, p of 0 is put 0 as n, that is 7 power 0 plus 2 plus 8 2 into 0 plus 1, which is equal 7 square plus 8 power 1. 7 square is 49 plus 8 is 57. Of course 57 is divisible by 57, so it's true. Then by induction step, P of k. By inductive step, put k, that is P of k, put n as k, that is P of k is 7 plus k plus 2 plus 8 power 2k plus 1. Of course, it is divisible by 57 because k value, that is ksn, that means any value for integer value for k, it is true. Then P of k plus 1, we have to prove it, that one 7 plus k plus 1 plus 2, because we are adding k as k plus 1. Here 8 as 2 into k plus 1 plus 1. Then this is 7k plus 1 means 7 power k plus 3. For that 7 take out 7 power 1 and 7k plus 2. That is a splitter. Then here 2k plus 2 plus 1. 2k plus 3 is there. For 8 power 8 square you are taking, and 8 power 2k plus 1. If you add these things, 2 plus 2k plus 1 is 2k plus 3. Here also 2k plus 3. Now 7 into 7 power k plus 2, 8 square is 64 into 8 power 2k plus 1. This is, here 8 square is 64. Now the 64 is splitted as 7 plus 57. Then we write here 7 into 7 plus 7 power k plus 2 plus 7 plus 57 into 8 power 2k plus 1. Then it is distributed. Yeah, that is 7 into 7 2k plus 2 plus 7 into 8 power 2k plus 1 and 57 into 8 power 2k plus 1. Here take out common 7. It is 7 power 2k k plus 2 plus 8 2k plus 2. Already we proved. Here number divisible by 57. A number divisible by 57 multiplied with 7 also divisible by 57. Here 57 is divisible, that is 57 into any integer, because k is an integer, 8 plus 8 power 2k plus 1 is an integer. So totally this number, this expressed number is divisible by 57. Divisible by 57. Therefore the result is what here, 7 power n plus 2. Therefore 7 for n plus 2 plus 8 power 2n plus 1. This number is divisible by 57. Divisible by by 57. Proved. Hence proved. Because this number is, we proved this number is proved divisible by 57. We have done. Please subscribe our YouTube channel.